Professor Bialis here. In this video we're going to be going over section 8.1, which is talking about linear functions. Now we talked about linear equations in the past, but now we're switching things up just a little bit. Whatever we talk about in this section was already covered back in section 3.5, but we're just adding the layer of functions in there, and you're going to see it really doesn't change much about what we've already talked about in the past. Okay, so let's recap just equations of lines and then see how this function idea is going to fit in. So when we deal with equations of lines, there's three main forms that we're going to be utilizing with equations of lines. And the first one is point slope form. Now point slope form is going to be given the slope m and any point on the line, we're going to call it x1, y1. Our equation is y minus y1 equals m times the quantity x minus x1. Okay? Now remember, where that comes from is basically just our slope formula, where it was y2 minus y1 over x2 minus x1, and we just multiplied out that denominator and brought it over here. Okay, so that's the gist of where this equation is coming from. Now, why do we have that equation? Because it's so easy to get into. There's literally an infinite number of points that I could pick off that line to plug in to this ordered pair. Okay, so that's why it looks a little bit more complicated than the others, but it's very easy to get into an equation form when we're using that. Now, our next one was our slope intercept form. Our slope intercept form is our good old y equals mx plus b. Okay, where m is your slope and b is your y-intercept. Okay, why we have that is because it's so easy to graph with. Okay, you plot your b, your y-intercept, and then you move with your slope up and over, and you have your points for the line. Now, this is where we're going to introduce the idea of a function. Okay, what we're going to really be focusing on and including here is function notation. Function notation is that f of x. Remember though, f of x is a fancy way of writing y. That's all it is a fancy way of writing y. So if we have y equals mx plus b, function notation is simply f of x equals mx plus b. That's it. That is the only added piece in this section from section 3.5. Okay? We are not going to be asked in this section for, okay, give me the equation of a line in slope-intercept form. They're not going to use that terminology. They're going to say, give me the equation of a line as a function notation. Okay? Or give me the function notation of that line. They're looking for slope-intercept form. Okay? It's just instead of a y, you write f of x. Nothing more than that. Okay? And then the last form that we talk about is standard form. Now, standard form looks like this. Okay, but there's also two rules that we need to follow. Now, when I say looks like this, the thing I want you to really focus on there is the fact that x and y are on the same side. Okay? And then the first rule is no fractions or decimals. And then also a must be bigger than or equal to 0. So you cannot have a negative in front of that x term. Okay? So these are our three main forms of an equation of a line. From there, we're just going to be building these. Now, as I did back in section 3.5, when I did these problems, I always went for standard form, and I'm going to do that here as well. Okay, because when I go to standard form, I'm also hitting this, I'm also hitting this, and then I end here. So I'm practicing all of them by doing it that way. So let's look at a few examples. Let's say I want standard form of a line with a slope of 3/5 and through the point 2, -6. Okay, so I have a line that has that slope and goes through that point. Okay, and I want to get standard form. Now again, when I get standard form, I'm also going to hit these. Why am I going to hit them? Because what do they give me? They give me a slope and a point. What form would I naturally just go to? Point slope form include or uses those two pieces of information. So I'm going to start with y minus y1 equals m times the quantity x minus x1. Okay, plug in y plus 6, because there's a -6 being plugged in on top of that minus, equals 3/5, and then x minus 2. If there's a problem in this section that says give me the point slope form, I would be done right here. Okay, but let's go further. I'm going to distribute remember, it's just 3 times -2 is -6, and then that 5 is there. Then I'm going to subtract a 6. Now here, remember, a 6, I want to write it in terms of fifths. So this 6, I want a 5 denominator, and what's 6 times 5? 30. So I have -6/5 minus 30/5 is -36/5. Now here's the thing. I want to keep going to standard, but if they ask you in the instructions, write this in function notation, then I would simply stop here and write it like so. And that's it. Okay? So all it takes to get the function notation is to get into slope-intercept form and then change the y to an f of x. Nothing more to it than that. Now, if I want to keep going for standard, if they ask me for standard, I don't change what I've done, I just keep going. And then I bring the x and y together. And we got that. Next, I have to follow these two rules. I can't have any fractions. So I'm going to multiply everything by a 5 to get -3x plus 5y equals -36. And what else is not okay about that? That negative out in front. So mathematically what I do is I multiply everything by a -1, but really for all practical purposes, all it takes is changing all these signs. And there's your standard form. Now again, by going there, I hit this, I hit this. But if in the instructions they say specifically, give me function notation, give me point slope, then you would just stop that process. Okay, so this process gives you anything and everything you would need. You just need to know when to stop. Okay, and again, you know when to stop by what the instructions tell us. It's not something we just have to know off the top of our heads. Okay? How about something like this? Again, I'm looking for standard form, and I have a line that goes through those 2 points. Now, in the previous example, I started with point slope form, but what am I missing? I don't have a slope yet. I can get a slope by going back to that slope formula. Whenever you use a formula, you write it down, okay? And then, second y is 6 minus first y of -4 second x is 2 minus the first x of 7. Okay? Two negatives make a positive. I get 10 over negative 5. Don't stop there. Always reduce that if you can. So I have negative 2. Okay? There's my slope. Now after that, if I'm using point slope form, that y minus y1 equals m, quantity x minus x1, then what we have to do is pick one of those points. Okay? It doesn't matter which point you pick. So let's say I pick this 7, negative 4. Then I would have a y plus 4 equals negative 2, then x minus 7. Okay? If you're like, I like the number 6, okay? That's my lucky number. Then if you're picking that, your point slope form would look like this. Both of those are correct. Okay? Point slope form is not a unique form for any given line. Now, if I want to then go for my slope intercept, aka what the section is going to call the function notation, I need to get the y by itself. So I'm going to distribute this and then bring that 4 over. And we got that. Now, I want to show you something. Again, you only have to do one of these, okay? But if you went here, don't say, well, my slope intercept's different. It's because I used a different point. It's fine. It should be the same. Let me show you. If I distribute this, and then I add the 6, as you can see, my slope-intercept form is the same. Okay, so there is one unique slope-intercept form for any given line. If they asked for function notation, then I use what I have so far, but I just switch it to this. That would be our function notation. Okay? Now, to get it to standard form, if they ask for it, I just continue. I keep the y in there, and I just add a 2x to get 2x plus y equals 10. And there's your standard form. So again, we found 3 possible answers that they could ask us for. Point slope, function notation, standard form. Okay? Follow the instructions and give them what they're asking for, and you'll do just fine. Okay? Now, one last thing I want to talk about is vertical and horizontal lines. Let's say they give you something like this. You're going through 5, negative 3, and you are parallel to y equals 8. Okay? Now, we should remember from the past, y equals 8 is a horizontal line. If I'm parallel to this, I'm also a horizontal line. Okay? So if I'm also a horizontal line, I'm going to have a y equals. And the only y value I touch is that negative 3. Okay? Now, when we deal with horizontal and vertical lines, we got to be careful with the forms that they ask us for. If they ask us for standard form in the instructions, then that's what we would have here. Okay? However, if they specifically ask for function notation, again, all that means is instead of a y, you would always write f of x. So the function notation form of this would be that. You're not doing the problem any differently, it's just how you present it at the very end. So again, this is function notation. Okay? Now, what about the alternative to that? What if we said Same basic problem, but we want it to be perpendicular. Perpendicular to y equals 8. Okay? Same situation, you got y equals 8. But if I want to be perpendicular, that means I have to be vertical. So if I'm vertical, I have to be x equals. What's the only x value I'm touching? 5. Okay? Now, here's the thing. If they ask for standard form, it's x equals 5. Can they ask us for function notation here? No. Because is a vertical line a function? No. Vertical lines aren't functions, therefore function notation should not be used. And remember, for function notation, we're changing out that y for f of x. There is no y. So in this case, it's not, well, if they ask for function notation, it should be x equals 5. They won't ask this type of a problem for a function notation problem. Okay? So again, the only thing for vertical lines is that standard form, which you would just leave as x equals 5. Okay? And then let's go a little deeper. One more example. Let's say we have something like this. Okay. Now this takes it a little step further from what you would have seen back in section 3.5. When we have these parallel perpendicular problems, they always had vertical horizontal lines. Here we don't. Okay. So let's see how this is going to play out. We have a point and we're perpendicular to that. Now what does it mean to be perpendicular? Graphically, you make that right angle. But algebraically, numerically, what that means is you have opposite reciprocal slopes. So by saying you're parallel or perpendicular to something, they're telling you the slope. We just have to dig in a little bit to find it. Okay? Now, if we're perpendicular to that, we need to first find the slope of this. That means get the variable y alone, get it in slope-intercept form, and read the slope. So, I am going to subtract 6x. And then divide by 2. And we have that. Okay. Now, what we should be taking out of that is that the slope of this is negative 3. If I am perpendicular to that, I have to have a slope of positive 1/3. Okay? The slope of that is negative 3. If I'm perpendicular, I have to have an opposite reciprocal slope. If I was parallel, then my slope would also be negative 3. But in this case, I'm using that 1/3. Okay? Now, I have a point, I have a slope, I can progress like I have in the past. Okay, so let's just run through that real quick. We've got our point slope form. I plug in my y value, which is going to be a plus 3 in this case. Then I plug in my slope of 1/3. And then I have x minus 8. Okay, I distribute. Get an 8/3. I subtract the 3. So y is 1/3 x. Now again, this 3, I'm going to think of as thirds. 3 times 3 is 9. So I have negative 17 thirds. If I wanted the function notation, if that's what they were asking for, I would just stop and change it to this. That would be my function notation. Okay? But if they don't ask for that, if they say standard, I just keep going. I don't change anything. I just go a little further. So I'm going to get the x and y on one side. I'm then going to clear the fractions by multiplying everything by 3. And then I have to fix that one last problem that negative can't be on the x. So again, I multiply through by a -1, which really just changes all the signs. And there we go. Okay, so again, if you look back on the 3-5 video, the only thing that's going to be different is switching that y to an f of x when they ask you for function notation. Beyond that, it is exactly the same. Okay, be careful with the parallel perpendicular concept. It's really nothing new. It doesn't really add too much complexity, but we have to be careful when we solve that for y. Okay, so please put in some effort on this section because there's a lot of algebra that is it's very easy to kind of derail you throughout the problem. So again, make it a routine, practice this, and you'll do great. Okay? Let me know if you have any questions. Keep working hard, and I'll see you next time.